I'm Jamie Zimmerman.
I'm Stephanie Gordon.
And I'm Ben too.
And we're Team Winterfell. And we're going to be taking you through the wonderful world of organ transplantation. From what organs can be donated,
to matching the organs and blood types,
to how they're preserved.
And it's going to be a long journey, so let's jump right on in. Now, when it comes to taking organs from one human and putting them into another one, there are a lot of steps to go by, starting with donation. The decision comes from prior discussion with the donor and the thumbs up from the family, and the donor has to be declared dead or brain dead. After they've been given the green light to take the organs, doctors begin testing. First, they test for blood type to see who will be able to receive the organ. Then they test for infectious diseases to make sure the organs are healthy and clean. They test for things like HIV, hepatitis C and B, as well as syphilis. And the kidneys are especially tested for tuberculosis. Afterwards, they take out the organs and preserve them. Now, what types of organs can be donated, you ask? Well, I'm glad you did. The heart, liver, lungs, pancreas, the kidneys, parts of the large and small intestine can all be donated by a deceased donor. And living donors can give up to one of their kidneys, parts of the pancreas, liver, lungs, and parts of the large and small intestine. And that's just focusing on organs. Blood, stem cells, and types of tissues can be donated by living and dead owners. Now, how does all this matching happen, you ask? Well, Ben will be telling you that.
blood type is a major factor when it comes to organ transplant. Before any matching can be done, the blood type has to be figured out. Though all blood is made of the same basic element, there are 8 different common types. The groups are A positive, A minus, B positive, B negative, AB positive, AB negative, O plus, and O negative. O plus being the most common among humans and is also the universal donor. How blood typing occurs is pretty simple. First, they draw blood from a vein, and the first step is they determine your blood group. They mix the blood with the antibodies against type A and B and see which one sticks or not. If they do, that means they react with the antibodies. The second step is called back typing. During this part, they take part of the blood without the cells and mix it with blood that is known to have type A or B, etc. What happens is, type A blood will repel against type B, and type B will repel against type A, and so forth. After blood typing and testing is done, the next thing is to get the organs out and preserve them, which is what Stephanie will be explaining.
After testing has been done for a match, doctors will have the surgery to remove the organ. A team of surgeons, nurses, the transplant coordinator, and an organ preservation technician are all present for the removal. Just before being removed, the organs are flushed of all blood with an ice-cold solution that contains nutrients and electrolytes to keep the organ healthy as it is being removed. They are then put on ice in sterile containers with preservation solution and immediately moved to the facility in which they are needed. Getting the organs to their places needs to be done as quickly as possible, seeing as each organ can only go so long outside of the body. Hearts and lungs must be transplanted within 4 hours, intestines can last 8 hours, pancreas is 8 to 12 hours, livers 12 to 18, I just said lizards, and kidneys can last the longest, that being 24 to 48 hours. Now, there are many types of solutions that preserve organs, which we will be talking about, starting off with Viaspan. Viaspan was created to preserve the pancreases, but was replaced by urocolons. It's still used for hearts and other organs despite there being better solutions out there. Urocolons, which replaced Viaspan, has been abandoned because it uses glucose, which doesn't preserve the organ well enough and can cause the organ to decay because the cells are using the glucose to create energy that essentially can't really go anywhere. Belzer UW, which took urocolon's place, is now the most used preservation solution used for livers, kidneys, and pancreases with excellent clinical and experimental preservation data. The 2 disadvantages are that it is pricey and comes in large 1-liter bags, which can make handling tricky, but besides that, Belzer UW is the best out there. HTK is used for cardiac preservation and demonstrates equal safety and efficiency in preserving livers and kidneys, and a solution called Celsior is also on the rise, but is only used for cardiac preservation. The way all these solutions work to preserve organs are pretty much all the same, which is what Jamie is now going to explain.
Now, the way all these wonderful solutions work is by using two main ingredients, those being lactobionic acid and hydroethyl starch. Lactobionic acid works by almost preventing osmosis. It slows down the cells so they don't swell up with water and burst, causing the organ to decay. Hydroethyl starch works by preventing edema. Edema is a type of fluid that occurs in organs, but mainly in the legs. It happens when tissue fluid that is kept in balance by homeostasis gets thrown off and increased in body cavities by things like cardiac arrest and death. Hydroethyl starch keeps the organs in homeostasis and prevents it from swelling with the tissue fluid. Basically, these chemicals work by slowing down the inevitable decay of the organ cells by slowing and maintaining the functions. There are a bunch of other things in these solutions, like allopurinol, which keeps blood plasma from filling up with too much uric acid, which also causes gout. Glutathione, which keeps major cell functions from being damaged, and just keeping the organs on ice keeps them from dying by slowing the molecules and making everything in the organ slow down and slowing their functions. Now, after all the preservation and transportation has been done, the organ has been implanted into the receiver, everything should be fine. The receiver is kept under surveillance to make sure their body doesn't reject the organ, and 48 hours after the organ has been implanted, they do another blood test. Afterwards, the receiver should do self-monitoring and will be given medication that helps make sure their immune system doesn't reject the organ by suppressing white blood cells from detecting anything wrong with the body. Then the patient is ready to live a normal life thanks to the beauty of modern medicine. Thank you for
watching, and remember,
only you can prevent forest fires.
That's not right. That's Smokey the Bear.
Oh, alright. Okay. You may save the lives of someone else by just being you. Always donate to blood drives and talk to your parents and your doctor about becoming a organ donor. I'm Jamie Zimmerman.
I'm Stephanie Gordon.
I'm Ben too.
And we're Team Winterfell. Thanks for watching.